According to the National Electrical Code, NEC Article 250.118, all metal structures or enclosures that are isolated from ground for electrical reasons and are likely to become energized during thunderstorms shall be grounded for lightning protection. This includes structures such as buildings, spires, antenna towers, water tanks, and fuel tanks. The NEC does not make a distinction between permanently and temporarily manned structures when it comes to grounding for lightning protection. Therefore, the grounding requirements still apply to the outdoor metal environmental enclosure, even though it is temporarily manned. The enclosure should be grounded using the following methods. Firstly, ground rods should be installed. Drive copper-clad steel rods at least 8 feet long into the ground in accordance with NEC Article 250.52. Secondly, concrete encased electrodes can be used. Embed copper or copper-clad steel electrodes in concrete in accordance with NEC Article 250.52. Thirdly, ground rings can be installed. Install a copper or copper-clad steel ground ring around the perimeter of the enclosure in accordance with NEC Article 250.52. Connect the electrodes to the enclosure using copper or copper-clad steel conductors sized in accordance with NEC Article 250.66. The fact that the structure is self-contained with no electrical service does not exempt it from the grounding requirements for lightning protection. In certain cases, a lightning protection analysis may be necessary to determine the appropriate grounding system design. This analysis should be performed by a qualified professional. Always check with your local authorities for any specific grounding requirements that may apply to your area. It is important to understand the purpose of grounding, which is to provide a low impedance path for fault current to return to the source, thereby tripping a circuit breaker or fuse and de-energizing the circuit. Grounding also helps to minimize the risk of electric shock by keeping the voltage of conductive surfaces close to ground potential. In the context of lightning protection, grounding provides a path for lightning current to flow safely to the earth, minimizing damage to the structure and protecting people inside. The size of the grounding conductor is crucial for ensuring that it can handle the fault current or lightning current without overheating or causing a voltage drop. NEC Article 250.66 provides guidelines for sizing grounding conductors based on the size of the service entrance conductors. The larger the service entrance conductors, the larger the grounding conductor needs to be. When installing ground rods, it is important to drive them deep enough into the ground to reach moist soil. This is because the resistance of the soil is a critical factor in the effectiveness of the grounding system. The lower the resistance, the better the grounding. NEC Article 250.56 requires that the resistance of the grounding electrode system does not exceed 25 ohms. If the resistance is higher than 25 ohms, an additional ground rod or other grounding electrode may be required. Concrete encased electrodes, also known as UFA grounds, are often used in new construction because they provide a very low resistance grounding path. The concrete helps to protect the electrode from corrosion and provides good contact with the earth. Ground rings are typically installed around the perimeter of a building or structure to provide a comprehensive grounding system. The ground ring should be buried at least 30 inches below the surface of the earth and should be connected to all of the other grounding electrodes. When connecting grounding conductors to electrodes or enclosures, it is important to use approved connectors that are listed for grounding purposes. These connectors are designed to provide a reliable, low-resistance connection that will not corrode over time. It is also important to protect grounding conductors from physical damage. This can be done by running them in conduit or by burying them underground. If a grounding conductor is damaged, it may not be able to carry fault current or lightning current effectively. Regular inspection and maintenance of the grounding system are essential to ensure that it remains effective. This includes checking the connections for corrosion, measuring the resistance of the grounding electrode system, and repairing any damage to the grounding conductors or electrodes. In addition to the grounding requirements for lightning protection, there may also be bonding requirements for metal enclosures. Bonding is the process of connecting all of the metal parts of an electrical system together to create a low impedance path for fault current. This helps to minimize the risk of electric shock and fire. NEC Article 250.96 provides guidelines for bonding metal enclosures. The size of the bonding conductor is based on the size of the circuit conductors that supply the enclosure. When bonding metal enclosures, it is important to use approved bonding connectors that are listed for bonding purposes. These connectors are designed to provide a reliable, low-resistance connection that will not corrode over time. It is also important to ensure that the bonding conductors are properly protected from physical damage. In some cases, it may be necessary to provide supplemental grounding for metal enclosures. This can be done by installing additional ground rods or by connecting the enclosure to a ground ring. Supplemental grounding is typically required when the enclosure is located in an area with high soil resistivity or when the enclosure is used to house sensitive electronic equipment. When designing a grounding system for a metal enclosure, it is important to consider all of the applicable codes and standards. This includes the NEC as well as any local codes or regulations. It is also important to consult with a qualified electrical engineer or grounding specialist to ensure that the grounding system is properly designed and installed. Proper grounding is essential for protecting people and equipment from electrical hazards. By following the guidelines in the NEC and consulting with qualified professionals, you can ensure that your metal enclosures are properly grounded and bonded. It is crucial to remember that grounding is not a substitute for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Grounding provides a path for fault current to return to the source, which helps to trip the overcurrent protection device. Without proper overcurrent protection, a fault current could flow through the grounding system for an extended period of time, potentially causing damage to equipment or injury to people. Therefore, it is essential to ensure that all electrical circuits are properly protected by overcurrent protection devices in addition to being properly grounded. In the context of a temporarily manned self-contained structure with no electrical service, the primary concern for grounding is lightning protection. While there is no electrical service to ground in the traditional sense, the metal enclosure itself can become energized by a lightning strike. The purpose of grounding in this scenario is to provide a safe path for the lightning current to flow to the earth, minimizing the risk of damage to the structure and protecting anyone who may be inside at the time of the strike. The grounding system should be designed to handle the high currents associated with lightning strikes. This typically involves using multiple ground rods or a ground ring to provide a low impedance path to the earth. The conductors used to connect the enclosure to the grounding electrode should be sized appropriately to carry the lightning current. In addition to grounding the enclosure, it may also be necessary to bond any metal components inside the enclosure together. This helps to equalize the voltage potential between the different components and reduces the risk of sparkover or flashover during a lightning strike. The bonding conductors should be sized appropriately to carry the expected bonding current. It is important to note that the grounding requirements for lightning protection may be different from the grounding requirements for electrical systems. The NEC provides specific guidelines for grounding electrical systems, but these guidelines may not be sufficient for lightning protection. Therefore, it is important to consult with a qualified lightning protection specialist to ensure that the grounding system is properly designed for lightning protection. The lightning protection specialist can perform a lightning protection risk assessment to determine the level of protection required for the structure. This assessment will take into account factors such as the location of the structure, the height of the structure, and the type of construction. Based on the results of the risk assessment, the lightning protection specialist can design a grounding system that meets the specific needs of the structure. In some cases, it may be necessary to install a complete lightning protection system, which includes air terminals, down conductors, and a grounding system. Air terminals are designed to intercept lightning strikes and provide a path for the lightning current to flow to the ground. Down conductors are used to connect the air terminals to the grounding system. The grounding system provides a low impedance path for the lightning current to flow to the earth. A complete lightning protection system can provide a high level of protection against lightning strikes. However, it is important to have the system designed and installed by a qualified lightning protection contractor to ensure that it is effective. Regular inspection and maintenance of the lightning protection system are also essential to ensure that it remains effective. This includes checking the air terminals for damage, inspecting the down conductors for corrosion, and measuring the resistance of the grounding system. Any damage to the lightning protection system should be repaired promptly to ensure that it continues to provide adequate protection. When selecting a location for the enclosure, it is important to consider the potential for lightning strikes. Structures that are located in exposed areas or on high ground are more likely to be struck by lightning than structures that are located in sheltered areas or on low ground. If possible, the enclosure should be located in an area that is protected from lightning strikes. This may involve locating the enclosure near other buildings or structures that are taller than the enclosure. It is also important to avoid locating the enclosure near trees or other tall objects that could attract lightning strikes. Trees can conduct lightning current to the ground, and if the enclosure is located nearby, it could be damaged by the lightning current. In addition to grounding, surge protection devices can also be used to protect electrical equipment inside the enclosure from lightning strikes. Surge protection devices are designed to divert surge current away from sensitive electronic equipment. These devices can be installed at the point of entry of electrical service or at individual equipment locations. It is recommended to install surge protection devices on any electrical equipment that is located inside the enclosure, even if the enclosure does not have an electrical service. This is because lightning strikes can induce surge currents in nearby electrical circuits, even if the enclosure is not directly struck by lightning. When selecting surge protection devices, it is important to choose devices that are rated for the expected surge current. The surge current rating should be high enough to handle the maximum surge current that is likely to occur in the area. It is also important to choose surge protection devices that are listed by a recognized testing laboratory, such as Underwriters Laboratories, UL. Listed surge protection devices have been tested to meet certain safety standards and are more likely to provide effective surge protection. Regular inspection and maintenance of surge protection devices are also essential to ensure that they remain effective. This includes checking the devices for damage and testing them periodically to ensure that they are still functioning properly. If a surge protection device is damaged or fails to function properly, it should be replaced promptly. In summary, grounding is an essential safety measure for outdoor metal enclosures, especially for lightning protection. The grounding system should be designed and installed in accordance with the NEC and any applicable local codes. Regular inspection and maintenance of the grounding system are also essential to ensure that it remains effective. In addition to grounding, surge protection devices can also be used to protect electrical equipment inside the enclosure from lightning strikes. By following these guidelines, you can help to protect people and equipment from electrical hazards. Remember to consult with qualified professionals, such as electrical engineers and lightning protection specialists, to ensure that your grounding system is properly designed and installed. They can provide valuable guidance and expertise to help you meet the specific needs of your application.